So today I'll be explaining you the solution of the problem A of code sensor division 2. So I'll give you the summary of the problem. If you want, you can read the problem yourself. And yeah, so the summary is you have to find the subarray which has the maximum bitwise AND, right? And it should contain that element. For every element, we have to find a subarray containing that element, which has the maximum bitwise AND. And the subarray size should be strictly larger than 1. So after we read the question, uh, there is an observation. The first observation is that you have to take the minimum sized subarray. Uh, it is possible because whenever you take bitwise AND of any two numbers or three numbers or four numbers, uh, the maximum number you can get is like the minimum of both the numbers, right? The reason that is true is because let's say if there is a number 7 and there is a number, let's say 5, and there is a number 4, right? So if we represent 7 in binary, right? So it would be 4 plus 2 plus 1, this is 111. So it would be represented as 111 in binary. And if you try to represent 5 in binary, that would be 4 plus 1, that would be 101, right? So when we take the AND of these two numbers, we can see that uh, always the number of ones will either be the same. uh, let's just remove 4 for now, and the AND of these would be 101. So we just see that when we take the bitwise AND, the number of ones just decrease or stays the same. So if we reduce the subarray size to as minimum as possible, then we can find the maximum subarray that has the maximum bitwise AND value. Yeah, so that was the first observation. And the second thing you have to look out was the maximum minimum subarray size is strictly larger than 1. So you can't just take a number 7 and just print it as it is, because that will be the maximum subarray and because you have to take a subarray of greater than 1 size. So, so what you have to do is, I would explain it with code now. So you just take the test cases, you take the n as input, and take another array d of n, which we will store the damages array, and we take the input. Now for the first, what you say, shop or something, for the first array element, the bitwise AND would be the first number and the second number. You don't have much choices for this. But for a number in between, like 412, now you have two choices for this number. Uh, this can occur in two subarrays of size 2, that is, namely 29 and 412 and 412 and 671. These are two subarrays that can contain this number, that is 29, 412 and 412 and 671. I'm talking about subarrays, so these have to be continuous. Okay, it's not a subsequence. So so uh, what we have to do is that we find both of these values, and we just find what is the maximum of both of these values, right? We just add them, and we store the maximum of these two values in the damages array, and that's what I have done. For I equals 1 to less than n minus 1, this is because for the last element also we'll only have one choice, that is to pair it with the second last element. So that is the code pretty much. So we just take the maximum of and of a of I and a of I plus 1, and the a of I and a of I minus 1, the previous term and the term next to it. We take the maximum of that in the damages array, and we just print out the damages array straight away. Yeah, so that was it for the first question. In the next video, I'll be explaining you the solution to the second question. Yeah, so please like, share, and subscribe if you liked what I did, if you understood the solution, uh, and just tell me in the comments what can I do better so that I I can grow and improve myself. Yeah, so if you have any other queries, I would love to answer them in the comment section. So yeah, thank you for watching.